OpenAI 发布了 O3以及 O4 mini 版本，它们看起来都很不错，起码从版本上，它们不是 GPT 4.1取代了 GPT 4.5，现在是 O3将取代 O1，O4 mini 将取代 O3 mini。O3拥有非常强大的图像推理能力，被 OpenAI 称为先进的 AI 系统，能够搜索网络并撰写报告。令人惊讶的是，O3能在推理链中直接调用工具。这一功能可能标志着模型直接使用工具的新趋势。从今天开始，Plus、Pro 和 Team 用户将在模型选择器中看到 O3、O4 mini 和 O4 mini High，分别取代 O1、O3 mini 和 O3 mini High。我会考虑测试一下，同时也会看看其他人怎么评价。我特别想看看它与 Gemini 2.5 Pro 的对比，尤其是在编码能力上的对比。这是 OpenAI O3和 O4 mini 的博文。这些模型在基准测试中表现出色，性能令人惊叹。按照 OpenAI 的说法，这些是迄今为止我们发布的最聪明的模型，代表了 ChatGPT 能力上的一个阶跃式变化，适用于从好奇的用户到高级研究人员的每个人。除了擅长使用工具，OpenAI 还表示，这是他们发布的第一个能够产生真正新颖想法的模型。信息量有点大，还是需要一些时间来解读的。我们先来快速浏览一下 OpenAI 发布的直播视频，我会穿插一些评论。很高兴能看到 Greg Progman。
We are going to be releasing two models, O3 and O4 mini. These are the first models where top scientists tell us they produce legitimately good and useful novel ideas. We've seen great results in law. Talking to one of my coworkers yesterday, he said that O3 came up with a great idea for system architecture. It's like we haven't really seen anything like this. And the thing that's really amazing about these models is that they're not just models, they're really AI systems. We've trained them to use tools, which is not something that we had done with our previous reasoning models. They actually use these tools in their chain of thought as they're trying to solve a hard problem. For example, we've seen O3 use like 600 tool calls in a row trying to solve a really hard task. And we're going to be making these models incrementally available starting today, rolling out as quickly as we can in our API and ChatGPT. And one thing that's very near and dear to my heart is their ability in software engineering, and not just producing sort of one-off pieces of code, but really working in real code bases. I found that these models are actually better than I am at navigating through our OpenAI code base, which is really useful.
Definitely
really,
better than I am.
That ship has sailed for me a long time ago.
Yes. But it just helps you get so much more done. And so we're really excited to bring these to the world and see what you will all do with them.
我来播放下一段。OpenAI 的模型现在具备代理能力，这倒提醒了我还有 Manners， 我差点忘记了 Manners AI， 它只是昙花一现吗？
All right, we're going to show you some things that O3 can do. I'll start with a science example. So this will be a physics poster. So I'm going to let O3 start thinking now so it can take its time. What I'm going to feed it is a poster of some physics internship that I did in 2015, so 10 years ago. And this poster, or the project, was supposed to estimate a quantity called the proton isovector scalar charge. It's a beyond the standard model of particle physics quantity that tells you how short-range interactions, how strong they are. And what you'll see is that the model, O3, is zooming in. It's kind of like browsing around. Here, I'll zoom out just to get a little bit better view. And it is kind of looking for the right quantities for the question I asked it, which is to basically find this result that I had and compare it to recent literature. But there's a small twist. The result actually isn't in the poster. And that's because I didn't have it yet. So although it's in like the final paper for this project, it's not in this poster. And I'm actually asking O3 to do the rest of the project for me, essentially.
He uses the same trick at OpenAI.
Yeah. It's true. Great. So it found the plot that I wanted it to find. It's supposed to figure out that it needs to like find the slope of this plot, extrapolate down to a specific like physical quark mass, and then like grab that quantity, and then actually apply another quantity to normalize that value. And I think it has already kind of figured out that this is what it should do, but it is just spending a little bit more time exploring the image, okay, it's good. It's now going to browse the web for recent results.
Yeah, why is it searching the web?
Well, I think I actually, did I ask it? I said, oh yeah, find any recent findings that have like updated estimates. So now it's like just looking at like the literature and seeing what people have done and how it compares to the result that it thinks that I eventually arrived at.
And how long do you think it would take you to do this task?
Quite a long time. Yeah, so I mean, it took me a long time just to remember what my poster even meant in the first place. And I also didn't even realize that the result wasn't there when I first asked it this question. It actually told me that, which was nice. So many days just for me to even like onboard myself back to my project, and then a few days more probably to actually like search through the literature. And I mean, it must have just read at least like 10 different papers in a few seconds for me. So that's a huge time savings. Great, so it has summarized my result here, and these numbers look correct to me. So it's figured out like there's like this unnormalized value that it's like estimated by extrapolating, and that when you multiply by this specific constant, that it will renormalize it. And it says, okay, you would have ended up with this, which is somewhat close. I think it ended up around like 1.2 in my paper. And then it compares with the actual literature here. So there's a few different estimates, and looks a little close, I'd say. So let's see what it says. It says my bear value looks high because it needs to be renormalized. That's correct. After you multiply by that, you get something that's more consistent with the state-of-the-art results. That's great. But it says my precision isn't as good as the state-of-the-art, which is fine. It was an internship.
Not bad for an internship.
Exactly. So
We'll allow it.
I'll take it. So it seems like it's still a reasonable estimate that maybe has a little bit more uncertainty than recent results, which is great. So the field has made progress, which is awesome to see.
这些是 O3 执行的复杂任务。在直播中 ，Greg Brockman 说，这仍然只是下一个 token 预测，因此他们特别指出，他们正在进行2种类型的扩展，仍然是预训练。然后用强化学习进行的后训练，那么他们的模型使用工具的能力也是通过这种方式扩展出来的吗？我们继续看一下这些模型的性能介绍。
So we wanted to start out by showing some results on standard benchmarks for these models in math, coding, and science. So in these plots, the dark yellow bars are the new set of models, and the light yellow bars are the old set of models. And we see a pretty substantial boost. So on Amy, which is a hard math contest, O4 Mini gets 99% accuracy with tools, pretty much saturating the eval. On Codeforces, these models get over 2,700, which place them in the top 200 contestants in the world. And GPQA is a set of hard PhD-level questions, and O3 gets over 83%, which is pretty incredible.
So beyond math science, we also want to share, a lot of you I know use these models for coding, and we share some practical coding benchmarks. So on Sweetancer, Sweetbench, and Ada Polyglot, we achieve state-of-the-art results with the model when it's allowed to use tools end-to-end without any harness or any specific things like this.
We also wanted to show some numbers for standard multimodal benchmarks. And these numbers are just crazy on MMMU, MathVista, Charchive, and vStar. So we really hope these models are useful for your multimodal tasks as well.
Yeah, this is really, applying the reasoning paradigm to multimodal, which was previously not possible. And now, as Brandon demoed, the model is able to manipulate the image directly in the chain of thought, and that leads to a huge increase in capability for multimodal. Yeah, finally, I want to share another few evals that we run externally. So Humanities Task Exam, as you can see, our O3 model is able to get close to deep research. But O3 will run much faster, and of course, we have much fewer rate limits in ChatGPT if you're using it in ChatGPT. So we think it's a very cool model if you do not need a full report like what deep research produces, but instead are still interested in some agentic behavior to help you grab information.
So in these plots, we show the performance on the y-axis against the estimated inference cost on the x-axis. And we see that O4 Mini is quite a bit better than O3 Mini for any given inference cost.
Additionally, one thing that is not shown here is that O4 Mini is a multimodal model, unlike O3 Mini. So if you need a small and fast multimodal reasoning model, I'm very excited for you guys to try out O4 Mini.
The results for O3 are even more stark. You can see that it can get the same performance with way less inference cost. And if you're willing to pay the same amount as O1, then you get a much higher score. So these are pretty amazing models.
Yeah, and this is why we're going to replace the O1 models with the new ones.
Yes. One thing we should mention quickly is that due to of the optimizations we've done to make the reasoning more cost efficient, and also the model more useful in general, it is not as benchmark optimized as the numbers we shared for the 12 days of Christmas. So there might be some small disparities up and down. Generally, it's gone up in multimodal, for example. We still think that this is a much better model because it's much more optimized for real-world use cases, and you won't have to wait as long when you're asking for an answer, which is a real thing with these reasoning models.
People are impatient.
I am impatient.
Yeah. So these models are a result of a lot of rigorous science, ingenuity, and craftsmanship. And we put in more than 10 times the training compute of O1 to produce O3. And it was a lot of hard work by lots and lots of people, but the end result was really beautiful to see. As we scaled up compute on the x-axis, the performance on evals like Amy just kept going up.
Yeah, so this is really us, going and retracing our steps through the GPT series, right, which was this kind of predictable scaling and pre-training. And now the goal is really we're trying to get through this scaling in RL and showing that as we put in more RL compute, we're also able to get commensurate gains.
这些思考模型是如何产生的呢？研究团队首先会挑选一个性能卓越的基础模型，然后通过强化学习技术，结合可验证的奖励机制，激发并培养模型的思考能力。那么，这些思考模型所依赖的基础模型究竟是什么呢？几周前 ，OpenAI 的 CEO 山姆·奥特曼曾提到，他们发现 GPT-5的表现远远超出了最初的预期，性能比他们想象中要好得多。因此，我推测实际情况可能是这样的：研究团队正在使用 GPT-5在不同训练阶段的检查点作为这些思考模型的基础模型。并在此基础上应用强化学习技术。随着 GPT-5的训练不断推进，每次暂停训练并对当前的检查点进行基准测试时，团队都惊讶地发现模型的性能在持续提升。这种提升似乎没有上限，表明模型的扩展规律目前呈现出近乎无限的潜力。OpenAI 还发布了 Codex CLI， 这是一个由 OpenAI 驱动的代理式编码工具。它能够在本地计算机的控制台上运行，虽然它实际上是由云端模型提供支持的。这是一个开源项目，它直接与 Cloud Code 竞争，功能上几乎与 Cloud Code 相同。Codex CLI 可以读取你计算机上的文件，也可以将文件写入你的计算机，因此你可以充分利用多模态推理、工具使用和思考的优势，同时让它在你的编码环境和代码库中工作。这非常酷，也非常令人兴奋。突然间 ，OpenAI 通过 Codex CLI 进入了我们的电脑，就像 Cloud Code 一样。你可以让 Codex CLI 进入全自动模式，让它在你的计算机上自由运行，执行命令并构建你所需要的内容，为编码体验带来全新的可能。好的，今天的视频就先聊到这里。如果你喜欢今天的节目，别忘了点赞、分享并订阅我的频道，及时获取科技资讯和深度解析。感谢观看，我们下期再见。